All right, so here's another example. We have a triangle up there. Notice that we know angle A, angle C, and side B. So that puts us firmly in angle, side, angle. And a little extra fun, we're going to find exact values. So no calculator approximations. We have to do exact values for this guy. So let's see if we can do that. Well, first things first, if we know two angles, it's easy to find the third angle. The third angle will be 180 minus 45 minus 105. That's going to be our B. So 180 minus, let's see, 180 minus 150 is going to be 30 degrees. So our B is 30 degrees, okay? Well, that's nice because notice that we have two kind of known common standard angles, 45 degrees and 30 degrees. We know the exact value of sine of 45 and sine of 30. So that tells me that I should be able to solve this triangle exactly. So let's do that. Okay, here we go. Well, we know sine of B over B. We know all of the values there. So sine of B over B. I know that my angle B is 30 degrees. I know that my side length B is 2. So let's use that to find, say, A here. A, we can think of, we know sine A over little a, but angle A is 45 degrees. So the only thing we don't know in this equation is little a. To solve for little a, I'm going to multiply both sides by little a, and then divide by sine of 30 over 2. So I'm going to start taking a little bit of shortcut here. That tells me that little a is going to be equal to 2 sine of 45 degrees over sine of 30 degrees. Okay? All right. So now we have to do this exactly. It means we can't go to our calculator at this point. Instead, we have to remember what sine of 45 and sine of 30 degrees are. If you don't remember, it's cool. That's why we have a unit circle, right? So if we pull up our unit circle real quick, okay, we need to know sine of 45. Here's 45. Sine of 45 is square root of 2 over 2. We also need to know sine of 30. Here's 30. Sine of 30 is 1/2. So we'll have 2 square root of 2 over 2. So 2 times square root of 2 over 2 divided by 1/2. Okay, so just substituting square root of 2 over 2 for sine of 45 and 1/2 for sine of 30. A little bit of simplification on top. I've got 2 and 2. So I end up with square root of 2 divided by 1/2. But that's square root of 2 times 2 over 1 or 2 square root of 2. So the value of our A is 2 square root of 2. Now let's find the value of C, and again, we're going to do that exactly. Okay. Well, we know that our sine of B over B is sine of 30 over sine of 30 over 2. And that's going to equal our sine of C over C. We know that our angle C is 105. Okay. All right. So that tells us when I solve for C, I'll move my C over. So I'll have C times sine of 30 over 2. Multiplying both sides by 2 gives me 2 sine of 105 degrees over dividing by sine of 30, sine of 30. Okay, now here's where things get fun, is what I would say. We know what sine of 30 is from our unit circle. We know that sine of 30 is equal to 1/2. So we have 2 sine of 105 over 1/2. Okay, now 105 is not one of the angles that appears on our unit circle, right? But if you remember from when we had our sum and difference formulas, we can calculate 105 by using a sum and difference formula. So let's see, I'm going to erase a little bit and give us some more space. Remind us of our sum and difference formula so that we can finish out this problem. Okay, so remember where we were. We're trying to find sine of 105, and I made the claim that we can do that using our sine sum formula. Sine of A plus B equals sine of A cosine B plus cosine A sine of B. What that depends on is our ability to write 105. So from over here, we need to be able to write 105 as some combination of the standard angles that we know. What do we know? We know 0, that's not very helpful, 30 degrees, 45 degrees, 60 degrees, 90 degrees, etc. Well, 105, I believe, is going to be 60 plus 45, which means that sine of 105, I can think of as sine of 60 plus 45, which means, using my sum formula, I can do sine of 60 cosine of 45 plus cosine of 60 sine of 45. Now we know what all of those are. Sine of 60 from our unit circle, excuse me, is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Cosine of 60 is 1/2. And sine of 45 is square root of 2 over 2. All right, awesome. Now we're going to algebra. Square root of 3 times square root of 2 is the square root of 3 times 2, or the square root of 6. Over 2 times 2 is 4. Plus 1 times the square root of 2 is square root of 2. Over 2 times 2 is 4. Common denominator already. So we end up with square root of 6 plus square root of 2 over 4. So that, remember, is what sine of 105 is equal to. Exactly. So coming back over here, we now know that C is equal to 2 times sine of 105, which is this nasty business, square root of 6 plus square root of 4. Oh, sorry, square root of 2, I can read. Square root of 6 plus square root of 2 over 4, all over 1/2. Dividing by 1/2 is the same thing as multiplying by 2. 2 times 2 gives me 4 times square root of 6 plus square root of 2 over 4. So I've got a 4 on top and a 4 on bottom. So final answer, square root of 6 plus square root of 2. So our C is exactly square root of 6 plus square root of 2. Awesome. Okay. All right, that was a great example. All right, let's work another example, this one related to the area of triangle. All right, before we work the example that I promised, I just want to think about area of triangles for a minute. Now, I bet most of you, if I ask you the formula for the area of a triangle, would say the area of a triangle is equal to 1/2 base times height. You are correct. That is 100% true. Area of the base times height. 1/2 area of the base times height. Here's the trouble with that. When we're talking about height for a triangle, height means vertical height. I always used to tell students that the height of a triangle is the height you need to get that triangle through the door, right? So in other words, to find the height of a triangle, we have to draw a perpendicular line, right? So this is the height of our triangle. So for this triangle, we could think of the area, our area, not to be confused with angle A there, but our area is going to be 1/2 this side length, that's our base, B, times our height there. Okay? Well, that's really great, except for oftentimes when we're dealing with triangles, we don't know this. We don't know the height, right? So let's see if we can use our law of sines to rewrite the height in a different way. Now, there's a couple of different ways to do this. Notice that when we dropped that height, we created 2 right triangles. If I look at the right triangle, this little guy here that I'm outlining in this purpley color, well, what's another way that I can talk about H? Well, I can think about H in relation to angle C. In other words, if I think about sine of C, sine is opposite H over hypotenuse A. So sine of C is equal to H over A. If I solve that for H by multiplying both sides by A, I get that H equals, A times sine of C. Looks really similar to what we did when we developed the law of sine. But what's the advantage to that? Well, that's going to let me rewrite my area formula as 1/2 B, which is side length B, times my H, I've now written as A sine of C. So here's another way we can think about our area. We can think of area as 1/2 BA sine of C. That's pretty handy because often when we're dealing with triangles, we know the length of the sides, not necessarily the height. Now, similarly, If I think about the other triangle that was created, which I'm going to kind of outline in blue, this guy is also a right triangle. And if I want to rewrite the height relating to the sides that I know, well, if I think about angle A, I can think about sine of A is opposite over hypotenuse, or h, over c, which again, solving for h by multiplying both sides by c gives me h equals c times sine of A. So I could also rewrite this formula as 1/2 times the base, here's my base, times my height, but now I can think of my height as c sine of A. So here's a second way to think about the area of a triangle. Now there's a third way. That third way is developed by kind of rotating the triangle and building your height another way. But the third way that we could think of this, right? There's lots of different ways we could think of this, I suppose. But we can also think of this as something like 1/2. So let's look at what we have. We have B and A and then sine of C. We have B and C and then sine of A. We've used sine of C and sine of A. Do you think we can write this formula with sine of B? Sure, and then what two sides will we have? Well, notice that if I have sine of C, I've got sides A and B. If I have sine of A, I have sides B and C. So if I have sine of B, I'm going to use sides A and C. All three of these formulas will give us the same area, but it's kind of handy because we don't necessarily have to know the height of our triangle. All right, so now let's use these in an example, okay? Okay, so now we're gonna work an example. I've got a triangle up there. We're gonna solve the triangle and then find its area, okay? So first let's solve this triangle. Notice that I'm in angle, side, angle situation. So angle, side, angle. So I can use my law of sines. Here we go. Before we even use law of sines, we can solve for this last side. I probably should put some labels on here, huh? Let's call this A, B, and C, which makes this side C, this side A, and this side B. We can solve for angle A using the fact that the angles of a triangle sum to 180. I'm going to do 180 minus 106.26 minus 36.87. And I get 36.87. So real quick, what does that tell us about this triangle? If these two angles are equal, what kind of triangle has two equal angles or two equal sides? An isosceles triangle. This must be an isosceles triangle. That means that side C should be equal to 5. Why? Because it's isosceles. That means two equal sides and two equal angles. We can check that fairly easily, right? If we wanted to know side C, using our law of sines, we know that sine of C over C is going to equal, excuse me, sorry. For example, sine of A over A. Well, we know that C is 36.87. We're trying to show that C should be equal to 5. We know that A is 36.87, which means, and we know that, sorry, that little a is 5. Now, just by looking at this, you should be convinced that this is 5. Sine of 36.87 over C equals sine of 36.87 over 5. Well, the only thing that will make this true is 5, but if you really want to check it, we know that C is going to be equal to sine of 36.87, this guy, divided by sine of 36.87 times 5. Well, sine of 36.87 divided by sine of 36.87 cancels, and we're just left with C equals 5. Okay, I believe it. C equals 5. We knew it had to equal 5. Now we've shown that it equals 5. Okay, well now what don't we know? We don't know our B, so let's find our B. We know sine of A over A should equal sine of B over B. So we know that our angle A is 36.87. We know that little a is 5. We know that sine of B, we know B is 106.26 degrees. And so all we're missing now is our little b. To solve for little b, I'd multiply both sides by little b. That gets rid of little b on the bottom here. And then to get b by itself, I'd multiply both sides by 5. So 5 times sine of 106.26 degrees. And then divide by sine of 36.87 degrees. I'm going to go ahead and put that in my calculator, double checking that my calculator is still in degrees. It is. So 5 times sine of 106.26 divided by sine of 36.87 gives me 7.99999. So B equals 7.9999. Wow. 7.9999. How many nines are there? 8, 9. Okay. So if we're rounding even to the nearest, say, thousandth, so tenth, hundredths, thousandths, well, that 9 is going to make this 9 round up, make this 9 round up, make this 9 round up, which means B is essentially 8 when we take into account rounding. Okay, great. All right, so now we've solved the triangle. We know all the sides and all the angles. Now we're going to find the area, and we can find the area using any of our 3 formulas. So let's just start at the top. 1/2 times B, our B is 8, times A, our A is 5, times sine of C, our C is 36.87. Okay, so this should give us the area of our triangle. Once again, I'm going to go to my calculator. So I have 1/2 times 8 times 5 times sine of 36.87, which gives me 12.0002, which I'm going to round to 12. So this is our area is equal to 12 units squared. Now, just for fun, you don't have to do this, but just for fun, we can also just prove to ourselves that these other formulas give the same area. So my second formula says 1/2 BC sine of A. So 1/2, my B is 8, my C is 5, and then sine of A, well in this case A was also 36.87 degrees. This is an isosceles triangle. This literally says the same thing. So that's going to be 12. That was boring. But this guy should be slightly different. So let's try 1/2 times our A was 5, times our C was also 5, times sine of B. Sine of B is 106.26 degrees. So let's plug that into our calculator. We should get 12, otherwise we broke math. So 0.5 times 5 times 5 times sine of 106.26 gives me 12.00001. We didn't break math. So these formulas, and you don't have to do all 3, you could just pick one, are another way to think about the area of a triangle, especially if you don't know the height of your triangle.